everyone. Welcome to our October JSE webinar. My name is Michelle Everson. I'm from The Ohio State University. And before I introduce our speakers for today, I just wanted to tell you a little bit about how our webinars work. So our speakers will be sharing their paper with you, and they'll be talking for roughly about maybe 20 minutes or so, and then we'll open things up for questions. Along the way, if you have any questions, please type them in the questions room, and I'll be sure to ask the speakers these questions at the end. And when the webinar is all wrapped up, we hope that you'll fill out the evaluation form that you'll see at the very end of the webinar. That'll show up once the webinar ends. So I'm going to go ahead and introduce our speakers. Today we have Leigh Harrell-Williams from the University of Memphis and Rebecca Pierce from Ball State University. Go ahead, Leigh.
Thank you. And we're going to be presenting our information that was came from our paper in JSE in March 2015. I'd like to take a moment to just sort of keep the inspiration from yesterday's World Statistics Day going. If you haven't had a chance to go out to the website, I recommend that you do. There's some interesting things out there, including the winners of the data visualization contest. So I'd like to take a moment and introduce you to our entire research team as it stands at the moment in terms of who worked on our paper. We started as a Cosmos cluster back in 2007 at USCOTS at Ohio State, and we had 3 research advisory board members, Felicity Enders, Randy Groth, and Larry Lesser, and then the 4 of us who were novice stat ed researchers, all various stages of our careers, but not necessarily really experts at statistics education research. And so we've morphed as the years have gone on, and Larry has become more of a regular member of our group than a research advisory board mentor. So I'd like to take a moment and see how familiar you are with our paper. And so you should have a poll that appears on your screen, and if you would take a moment to answer the option that best describes you. Well, it seems like we're not getting any more responses here. So we have about 80% who haven't read it and 10% who answered what paper. Love you guys. And then 10% who said they read it thoroughly. So we're not going to give all the details away, but we are going to certainly highlight certain things in the paper. So one of the things I do want to talk about a little bit is where we started. And so as you can see, there are numerous reasons why, as a research group, we'd be interested in studying teacher efficacy. Some are listed on the yellow bar on this slide. And when we were doing our initial research to look at what we're interested in, the measures that we found dealt with attitudes towards statistics, learning or doing statistics, statistical knowledge, and statistics anxiety. We found no instrument that measured exactly what we wanted to measure. So we have another quick poll for you. We have a lot of acronyms going on that last slide, and so we'd like to know which of these instruments, the cells, SATs, SETs, or chaos, measures self-efficacy to teach statistics. Please choose the one that's correct. Okay, so that was a sort of easy question for you all if you read the title of our paper. So obviously the answer to that is the SETS instrument. So I'm going to talk a little bit about the development process. And so this part of our work is actually not described so much in the JSE paper, and we have a paper in the Journal of Psychoeducational Assessment that talks more about the activities that occurred early on, including looking at the GAISE and state standards at the times. We started pre-Common Core, but the Common Core was heavily influenced by the writers of the GAISE document, and so they luckily aligned for us. So the middle school SETS instrument has 26 items, and these pre-service teachers are asked to rate their confidence in teaching middle grade students the skills necessary to complete the following tasks using a scale from 1 to 6. We chose a 6-category scale so that it was similar to the current statistics self-efficacy scale and the self-efficacy to learn statistics scale. If you look at the appendix in the JSE article, we do have the items listed, and we have them listed based on the 2 factors that came out of our factor analysis. If you're interested in seeing all the items, I only put a few on the slide to make it legible, but you're welcome to check out the JSE paper. If you're interested in using the instrument, at the end of the slides we have contact information. So, once we felt comfortable with where the instrument, the wording of the instrument, we started doing data collection for validation purposes, and one of those analyses that came out was looking at the psychometric properties of the instrument. But then we wanted to know what sort of the practical information that we could learn from the data. So what are we learning that can influence further research or our further activities? Before I start, I'd like to get into the analysis part. I'd like to see how familiar you are with the with Rasch measurement, Rasch analysis, and a rate map, because I'll be presenting some information from that. So if you would answer the poll and let us know how familiar you are with these concepts. Okay, I'm going to go ahead and close the poll. I haven't been showing results, but I want to give you a little, hopefully you can actually see these now, that about 40% said you've heard of Rasch, 20% said you have heard of Rasch and a rate map, 10% said you actually performed some type of Rasch analysis, which is exciting for me. I always like to see that in an audience. And then 30% would like me to take my time, which that is obviously not a problem. So let me talk a little bit, I'm actually going to go back to this slide. Let me talk a little bit about the Rasch framework and what that means in terms of our work and the analysis. So if you think of traditional modeling of achievement data or personality data, you're looking to create a model that best describes the data. Rasch measurement has a philosophy that is slightly different than that. It's about obtaining data which fit the measurement model. So the focus on Rasch is not just on analysis, but we will spend most of our time on that. The focus on Rasch is a philosophy of whole that spends as much time on the instrument development and careful considerations using test blueprints. And so it's the idea that you have a lot of work done up front, and then when you go to do the analysis, the model is already chosen for you. So when I say the model is already chosen for you, there are various Rasch-based models. The simplest, which is actually called the Rasch model, uses a logistic-based curve, and it simultaneously models probability that a person gets a specific item correct. So the probability that person J gets item I correct. In our analysis, we're not looking at achievement data, so we're not looking at correct or incorrect. We're trying to model how much of a construct a certain person has. And so we are using a model that is based on polynomous data, since we have 6 response categories to each of our items. So as I mentioned, the model will give us information about a person's ability, which in our case again is how much of the construct they have displayed, and this idea of item difficulty or an item parameter. And in our case, that's going to indicate how hard it is for the person to use a higher category, like a 5 or a 6, versus the lower category, like a 1, 2, 3, or 4. So this is the rate map, and this is the actual figure out of our paper. And so let me explain this. It looks a little overwhelming at first, but really it can be broken down into thinking of this as side-by-side histograms. So on the left-hand side of the person item map, or rate map, named after Ben Wright, those are log odds units, or logits. And you can see on our graph it runs from -3 to +4. And so the smaller numbers, -3, -2, -1, means that the person has less of the construct. So they are less efficacious about teaching these concepts. The higher numbers, 2, 3, 4, indicate that they are more efficacious about teaching the items that are on the scale. So they have more self-efficacy to teach statistics. We're not going to focus too much on the distribution of people, but you can see that sort of what in the middle is indicated by the pound sign. The pound sign just means that there's more than one observation at that point. What we really want to focus on is the small distribution on the right-hand side, which is the distribution of items. And you can see they're labeled item 1, 2, 3, 4, all the way up to 26, since we have 26 items on the scale. I'm actually going to enhance that image so that we can talk a little bit more about what we found. So one of the things we found was that the level A items had a lower difficulty, meaning that people were able to rate them with a 6 or a completely confidence more frequently than using a lower number. The numbers that are on the top half, between 0 and 1, those are the items that are considered to be more difficult. Pre-service teachers were having a more difficult time answering those items with a 5 or a 6. So let's look a little about thinking about this in something that, in a way that, visualization way that might be more familiar to you. So we have ordered these items. If on the left bottom axis you can see item 10 is the first item because it is the easiest item, and all the way over on the right hand side item 23 is the last item because it's the hardest item. And the colors represent the percentage of people who used each category. So you can see for item 10 about 40% used completely confident, whereas for item 23 hardly anyone used completely confident. So this is just another way to think about some of the information you're getting from the rate map in a format that you may be more comfortable with. So which items did the teachers have the most self-efficacy to teach? We, again, the lower of the number for the difficulty means that the easier the item is. So they were most efficacious about teaching the students that statistical results may differ from one class or one group to another. And so you can see that these are all actually items that match up to level A of the GAISE guidelines. So this is a little unfair because you do actually have the slides, but I want to see if you can guess which concept the pre-service teachers actually had the hardest time, or they felt the less efficacious about teaching. So they had the hardest time answering with a 6. Okay, so we have about 9% said describing a univariate distribution, 55% said variability across samples, 9% said comparing two distributions, and 27% said measures of association. So out of the options, the last 3 actually were ones that pre-service teachers felt less efficacious about, where they had a hard time rating with a 6. But out of those, the measures of association was the most difficult. So if you look up here, we see a difficulty estimate of 0.74. So that was the hardest item for them to rate with a 6. You will see, though, that the other answers, B and C, were in here. So item number 21 asks about explaining the difference between 2 or more groups, and item 18 looks at interquartile range, 5-number summaries, and box plots for comparing distributions. And so that these weren't, that's not an unreasonable answer to our quiz, but it just wasn't the right answer. So let's think about this for a moment in terms of what those items are generally talking about. And so pre-service teachers report that they feel most efficacious about teaching about the generalizability of results, variability among results, and creating and using graphs and tables to summarize distribution. Similar to if you imagine that the graphic on this slide represents an activity that a pre-service teacher would have students in their class complete, and the graphic on the right-hand side would be the student, of course, creating the actual bar graph. So summarizing the items that pre-service teachers reported feeling less efficacious about, the first one is question generation. So generating a question that doesn't have a yes or no answer. There were 2 items about association, and then there were the 3 items about group comparisons. So the box plot here is just meant to represent that if the pre-service teachers gave their students a question or wanted to have their students answer a question using something like this graphic, the pre-service teachers weren't feeling very efficacious about teaching their students the skills to make group comparisons. These results aren't really surprising. If you look at the JSE paper, we actually cite several studies that have shown that pre-service teachers have a higher competence in computation than in interpretation. So where are we going with this research? Well, we have developed a high school sets instrument that has extra items that are related to the Common Core high school data analysis strand. But part of what we didn't get at with our initial work with the middle school pre-service teachers was why. So why did they feel less confidence? Was it a matter of not having exposure? Is it a matter of actually having seen it taught in a classroom and realizing that it is difficult for the students to grasp? And so those are things that we're currently working on and hope to have some more information out in publications soon. One of the things we mentioned in the JSE paper is that we didn't simultaneously look at their self-efficacy as a self-report and a measure of knowledge. At the time that we collected this data, there was no knowledge measure that matched up to the topics that were in the middle school or high school standards. Everything was geared more towards AP or college level introduction, and that has a lot of formal inference, whereas the middle school and the high school standards are more informal inference. So I do want to mention in ongoing work, even though it's not ours, is that Holly Lynn Leigh and Jennifer Nickel at North Carolina State are working on a study that's looking at both using the sets and using the instrument that Tim Jacoby worked on, the locus instrument. So if you're interested in using our sets instrument, please email Rebecca. Her email address here is listed, and we'll send you the formatted PDF to have your students hand fill. As I mentioned, Holly Lynn has been using the instrument, and they have a version that's electronic, and I also have a poll that is electronic. So if you are interested in those, we can actually help you with that as well. And for your future use, we have sets references on the next two slides, including that JPA paper I mentioned that describes our early work.
Well, thank you so much, Leigh and Rebecca. So now is the time for questions. If you have any questions, please go ahead and type them into the questions room or the questions box. And I know that a couple of your co-authors are here in the audience, Larry and Alejandra, and I will unmute them in case they have anything that they would like to add to this conversation. Okay, so you're both unmuted if you want to say anything. So again, please let us know if you have any questions for our speakers today. We have a very quiet audience.
Yes, we do. I would just like to say that I wasn't speaking during the presentation because we were having difficulty with my audio. So, but apparently, you can hear me now.
Yes, that was Rebecca. Thank you, Rebecca, for being here, and I'm sorry we had those audio issues.
Yeah.
Okay.
If anyone is interested in learning more about Rasch methodology, you are also welcome to email us, and we can give you some references about that.
I think you might have just answered the question that came in here. Yeah, so there was a question about what resources do you suggest to learn more about the analysis part of this paper. Okay. So yes, please contact the authors. They'll be a great source of information. Well, I don't know if someone's typing in a question. Oh yes, do you know any measures for math teachers?
Are you looking for math teacher self-efficacy, or what thing for math teachers? Any self-efficacy. There is one, and I'm going to get the acronym sort of messed up. It's something like the MTSEI. Yeah, email me, but I think we also cite that paper in the JPA paper, but I can definitely get you the reference. There we go. It's the MTEBI.
Oh, good.
And it's an adaptation of the science teaching efficacy belief instruments by Riggs and Enochs. Thank you for sharing that, Alana.
Yes, and that is mathematics in general. and a group of us here in Texas are working on one that is just for algebra, efficacy, to teach algebra, and we're taking some of the things that we learned with the statistics one with sets to get the algebra, to develop the one for algebra. So if you are interested in particular algebra self-efficacy, then you can contact me, Alejandra Sorto.
Another question's come in, Leigh. Did you look into the students' SE or self-efficacy?
So our group was the pre-service teachers, so they were the students in the classes that we were assessing. Mm-hmm. These were not in-service teachers who were already teaching. So there were no. So in essence, these are the education students. Self-efficacy. The pre-service teachers are the undergraduate students.
Yeah, something interesting to look at will be in-service teachers and the relationship with their students, either achievement or beliefs about learning statistics.
Mm-hmm. We have not done like a large-scale study with in-service teachers.
So are there any last questions for our speakers before we wrap things up?
I'd just like to thank everyone for showing interest in our topic, and if we can be of assistance, please do contact us.
Thanks, Rebecca. We might have one more question here coming in. Okay, yep, so someone's typing a question.
Yeah, if you want to learn more about Rasch, I can send you various references. In the JPA paper, we cite Wolf and Smith 2007. There were 2 articles that talk about instrument development. But if you contact Rebecca and the email on the slide, then she can forward it to me, and I can definitely send you lots of information about Rasch, either in terms of looking at looking at a knowledge framework or in a personality Likert scale type question instrument.
Well, thank you again, Leigh and Rebecca, for being here to present. Thank you, Alejandra and Larry, for also being here in the audience to support your co-authors. One more question. Do you think PSTS, I'm not sure what the, can you see that, Leigh?
Teachers.
Do we think their preparation has anything to do with their self-efficacy? So I don't want to let the entire cat out of the bag in terms of our paper that we're working on right now, but we did collect data where we asked the students, or the high school pre-service teachers, to list the top item that they were most efficacious about and the item that they were least efficacious about, and explain to us why they rated those 2 items that way. And so there was some indication that we didn't spend a lot of time on this topic in our class, but there was also some indication of it's been a while since I've had my statistics class, and then there were some other really interesting things, such as one student had done student teaching already, and they saw statistics being taught in the high school classroom and realized, well, this is way harder than I thought it was going to be, and so that was why they rated certain things harder.
Okay, well, thank you again to our authors for presenting their work today from JSE. And I just want to make a couple quick announcements before we wrap up. So there is another teaching and learning webinar coming up next Tuesday, October 27th at 2 p.m. Eastern. That'll feature Alan Rossman and Beth Chance talking about batting for power. And then next month on Wednesday, November 18th at 12 p.m. Eastern, we'll have another JSE webinar, and that'll feature Amy Nowacki talking about her March paper called Teaching Statistics from the Operating Table, Minimally Invasive and Maximally Educational. So we hope that you'll join us for that. We'll soon have that posted on on the CAUSE website for you to sign up. So thank you again, everyone, and I hope you have a nice afternoon.